All right, let's talk about something that feels like it's straight out of science fiction: 3D printing. I mean, the whole idea is amazing, right? A future where you can just create anything you can imagine right on your desktop. But here's a question: is this amazing revolution in manufacturing as green as we all think it is? Let's dig in. So, the core idea behind 3D printing, you might hear it called additive manufacturing, it's just elegant. Think about it. Old school manufacturing, you'd take a big block of something and just carve away everything you don't need. 3D printing does the exact opposite. It builds things up one tiny layer at a time. This means you can create these unbelievably complex shapes with almost zero material waste. And because of that, it's gotten this reputation as a huge leap forward for green manufacturing. But hang on a second. While we're all, patting ourselves on the back for saving all that material, there's another resource being gobbled up that almost nobody talks about: electricity. So what is the real energy price tag for turning a file on your computer into a physical object in your hands? And that right there is the big secret we're diving into. We see 3D printing marketed as this super green technology, but its energy use? It's basically a complete black box. For most people, there's just no simple way to know how much juice their printer is really using. Okay, so this is where things get really interesting, because we're about to bust a huge myth. If you asked me, I'd guess all those little stepper motors, zipping the print head back and forth, would be the biggest power draw. Makes sense, right? Well, it's wrong. The research shows the complete opposite. The real energy hogs are the thermal systems. Yep, the heated bed and the nozzle that melts the plastic. They are the ones guzzling all the power. So why don't we know this? Well, it's pretty simple, actually. Most of the printers you and I would buy just aren't built to tell us. They don't have built-in energy monitors that are any good. And those estimates your software gives you, yeah, they're often wildly inaccurate. They don't factor in real-world stuff, like what's the temperature in the room, and they totally ignore all the energy that gets wasted when the printer is just sitting there waiting. Okay, so to fix this, we've got to make the invisible visible. We need to see that energy consumption, and that's exactly what a group of students decided to do. They built this really clever little IoT device they called an energy tracker specifically for 3D printers. And this awesome piece of work comes from a student project over at the University HUSSEIN in Malaysia. Their whole goal was to build a system that was, one, super accurate, but also, and this is key, low cost and easy for anyone to use. They wanted to give everyone the power to understand the true energy footprint of what they're making. The best way to wrap your head around what they built is to just think of it like a Fitbit, but for your 3D printer. Seriously, instead of tracking your steps or your heart rate, it's tracking voltage, current, and power consumption, all in real time. It gives you this complete health checkup of your printer's performance. And here you can see it go from an idea to a real thing. On the left, that's the blueprint, the system diagram. And on the right, that's the actual assembled prototype. It's so cool to see a clever design become this tangible solution that's ready to start pulling in data. All right, so how does this little gadget actually work its magic? Well, they broke the whole system down into a really simple 3-step process. It's this really elegant 3-part architecture. Step 1 is sense. There's this little non-invasive sensor that you just clamp right onto the printer's power cord. No complicated wiring, it just senses the flow of electricity. Step 2 is send. A tiny but powerful microcontroller, an ESP32, acts like the brains of the operation. It processes the data and sends it wirelessly up to the cloud. And then, step 3, see. You get to see all that data visualized on a mobile app, and it's all logged automatically into a spreadsheet for you. Sense, send, and see. It's that straightforward. And what you get out of this is just this incredible, super detailed stream of data. We're talking a new reading logged every 5 seconds. This creates what the researchers call an energy signature. Think of it like a unique fingerprint for the power used by every single print job, from the moment you hit go to the very end. Okay, now for the payoff. This is where it gets really good. After they built this thing and started collecting all this data, what did they actually find out? What secrets were hiding inside that energy signature about how these printers really work? And here it is, the big one, the single most important finding. Their data confirmed that those thermal systems we talked about, the heated bed and the nozzle, can eat up a jaw-dropping 70% of the printer's total energy. 70! So the takeaway is crystal clear. If you want to manage energy use, you have to manage the heat. But wait, it gets even more surprising. When they dug into the data, they found that the single biggest power spike, the moment the printer is drawing the absolute most electricity, happens right at the very beginning. The biggest energy hit is taken before the first layer of plastic has even been put down. This chart just lays that aha moment out so perfectly. Look at that massive energy spike during the preheating phase. It's huge. Then it drops down to a pretty stable medium level while it's actually printing. And finally, it trickles down to almost nothing when it's just sitting there idle or cooling down. That pattern right there is the printer's energy signature. So, what's the point of all this? I mean, what do we do with this new knowledge? Well, it's not just about collecting cool data points. It's about using this information to build a smarter and, honestly, a much greener future for manufacturing. Really, it all boils down to one thing: turning data into actual decisions. Once you know your printer's energy signature, you can start making smart choices. You can tweak the settings to save real money on your power bill and seriously shrink your environmental footprint. And you can do all that without messing up the quality of your prints. And this table just perfectly sums up why this IoT approach is such a game changer. Look at the difference. With conventional methods, you get a vague total number eventually. But with this system, you get super detailed, real-time data that you can check from your phone anywhere. Everything is automated. The whole workflow flips from being manual and reactive to being intelligent and proactive. It's a whole new ballgame. Now, this whole project was focused on just one 3D printer. But it leaves us with this huge, powerful question to think about. What happens when we take this same idea and apply it to an entire factory floor? Imagine 100 machines, all with their own energy trackers. The potential for a truly smart, truly sustainable industrial revolution, it's just absolutely immense.